In the previous video, we calculated some specific process of the cell neutrino decay to the off-cell charged bosons around the neutrino. And in this videos, I will talk about also some of the beyond standard model Harvey particle. This is some of the SUSY, some of the stop quark decay to the top and the one neutralino. This channel is possible as some super patterns of this diagram. There are two top and the one hypercharged big gauge boson is possible. And as a super patterns of this diagram, this vertex, one stop quark and the top quark and the neutralino with the binary component is possible. So Lagrangian can be written like that with the binary component. And this is a simple process, so the amplitudes can be written by just a coupling C1 and the two spinors for the top and the neutralino, top and neutralino. So I will assign the numbering 1 to the top quarks as initial particle, and the top quarks as a number 2, and the neutralinos as a number 3. Then the scales of these amplitudes, and we should consider spin sum of such a scale. So there are one of the four factors for the undetermined binary product type, and there are spin summations for the two spinors binary product types. So it turns out the thrice, and by using the thrice theorem, there are two gammas in the P3 and P2, so it gives a Z menu. So the P2 dot P3 such inner products is turns out, and for the mass term, there are M and MT, and for the one gamma matrix term, it gives a zeros for the twice calculations. And after that, such as scaling the amplitudes and the calculate the spin sum, let's determine the kinematics. We will start the CM on the last prime for the mother particle for the one. So the P1s are set to be the capital M as a mass of the stop quarks, and the three momentums are set to be the GL. And this is the CM prime. So the for the particle 2 and 3, the three momentum direction is upper side. And the energy E2 and E3 is given by the functions of these three momentums and the mass of the top and the mass of the neutralino side. So we should obtain the P to the P3 only. There's a very simple case. There are no propagate C3 in this diagram. And the P to the P3 is given by the E2, E3 plus P square. And by inserting this relations E and P and M, and we can use the Bellamy golden rule for the CM prime with the two-body decay, and this P is the binary particles as the momentums in the CM prime, and we should expand this sort of such a momentum P undetermined variables with the known variable, like as the mass of the M and the mass of the top and the mass of the neutralino. So by using the energy conservation, this M should be the same with the E2 plus E3. So it satisfies these relations, and this is E2 and E3. So by using this box, the energy, especially this three momentum of the binary particle, can be determined by the energy conservation conditions. So let's consider this energy conservations here. So there's M and the E2 and E3, and by scaling sort of both sides, there's the two P scales, MT scales, and MN scale, and the two roots of the P scale plus MT scale, which is E2, and the roots of the P scale and MN scale, which is E3. And by scaling again, we want to focus on the P scale, so the last make the constant terms in the one term, and there are four P scales and 4P4 scale and 2P scale. This is the left hand side, and for the two roots, it appears such a thing. And there are p-fourth terms that is cancelled out in the both sides, and also the empty squares and p squares disappear, and m squares and p squares that disappear. So the remaining terms in the left-hand side is m square minus m t square and minus m square and the overall square, and the minus 4m square and m t square from the right-hand side, and the last moves the momentum p terms here. So by this, we can find the solution for the binary momentum, three momentums. And by using the some factorizations for the numerator here, this is I square minus b square form, so it can be written like that. So we can rewrite the factorizing instead of m square, so that the remaining term becomes the mass losses here. So it means that when the capital M top quark mass is the same with the summation of the top quarks and neutralino, this becomes to 0. So the this channel is only allowed when the capital M is larger than the MT top quark mass and the MM neutralino. And when it becomes equality, it is kinematically forbidden. So also it implies that if the initial particle mass and the binary particle mass summations are similar, or the standard space becomes small. So also the wishes to determine that E2 and E3, E2 is given like the P squared plus and T squared and root, and E3 for the neutralino mass. So if we insert the P inside in there, there are m squares minus m t square minus such a form comes from the p squares in here and m t squares in here. So there are from this scalar term, there are 2 something and something and minus 2 something and something, but such a 2 plus 2 mtmn becomes a minus 2 mtmn. By this term there are minus 4, and minus 2 capital M and MT squares becomes a plus 2 because there are minus 4. So we can rewrite this M square, MT square, and minus MN square, since the minus 2, since the plus terms correspond to the capital M and MT. So the root becomes disappear. So the E2 can be written like that. This is a usual and a typical results in the two-body decay. Also similarly, we can obtain the E3 as a function of only the mass of the initial and the binary particles. So the all the 3 momentums terms of the binary particles that disappear. This is the very important characteristic of two-body decay, so that there are no continuous spectrums in here. So by using this spectrum, we can rearrange the P2 dot P3. So P2 dot P3, this is a E2, and this is a E3, and this is a P square. And by this, there are A square minus the B square terms in here. So here A plus the B and A minus B. And from here, this is a P square. So it gives this term. Already we found this in the above. And from the first term, we can obtain the A square minus B square term form. And from the second term, also we can obtain the A square plus B square plus C square plus 2ib minus 2bc minus 2ic term, and such a minus 4 gives the minus 2 term here. So this term, this mn, mt scales terms all disappear. There are plus 2 plus the minus 4, and also there are mt both power, mn both powers that disappear from this term. So the only remains term is 2m both and the minus 2m scales mt scale and minus 2m scales m and scale. So the capital M scales the common term, and thus there are 2 factors, so these factors that disappear. So the result is given by the m scales minus m scale minus m scales for the P2 dot P3. This is for P2 dot P3. So So remember that the parameters golden rules are given like that. So for the center of the master and the primes and antibody decay, and it gives the following result. So there are coupling term and the binary components of the neutralino, and the denominator and arm squares will be disappear. So the focusing that this is the P, and this final terms correspond to the P to the P3, and by factorizing is the sum of the mass term, these terms will be disappear, and only the one capital arms that remain, and the remaining terms are almost the dimension less. So by using the dimensions analysis, this is one of the times the mass dimension, so the dimension unit is the consistent, and for the remaining term from the this P to the P3, it gives the this term, and from the P3 momentum of the binary particles, there it gives this term, and this terms mean that the kinematically allowed or forbidden for the mass conditions of the top quark, the neutralino top quark. So, so that this is a binary result. Decay light for the top quark to the top quarks and the neutralino, and it gives us some of the phase-based factors. The overall factors are given like that, and the only free parameters in here is some of the binary components of neutralino, and the top quark mass here, and the neutralino mass here, and the top quark mass is fixed in here. So this is also very good example to find some of the decay light with some of the kinematics or Bowman diagram rule, and some of the energy conservations and parametric rule in the standard model of the supersymmetric theory.